Good evening, students. So we are starting another lecture that is related to protein. We are now talking about the building blocks of protein. They are amino acids. So first we have to set the objectives of today's class. First we'll define amino acids. Then we'll discuss the basic structure of amino acids. Then we'll discuss certain properties related to acid-base properties of amino acids. And lastly, we will discuss classification of amino acids. So amino acids are the monomers that make up proteins. Each amino acid has same fundamental structure. So what is the structure? So it has a central carbon atom, which is known as alpha carbon. And with this alpha carbon, one amine group is attached. That is NH2 group is attached to this alpha carbon, and another end a carboxylic, that is COOH group, is attached. So there are two types of amino acids. One is standard amino acids and non-standard amino acids. In our biological system, more than 300 amino acids will present, but among them only 20 are alpha amino acids and they are natural amino acids. So they are called standard alpha amino acids. Rest are non-standard amino acids. So these are amino acid derivatives found in protein and non-protein amino acids. So this is the basic structure of amino acids. The C is the central chiral carbon. Amine group is attached in one end. COOH carboxyl group is attached in another end. Hydrogen group is another end, and R is the side chain and the fourth end. So this is the basic structure of amino acids. Now regarding configuration, for all common amino acids except glycine, the alpha carbon is bonded to 4 different groups. So alpha carbonated is the such chiral center, but not in case of glycine, because it is attached to molecules of hydrogen. Instead of 4, there are 3 types of different groups are attached with this chiral central carbon. So in case of glycine, it is not chiral, but in other amino acid, it is chiral center. Amino acids have the existence of both a basic and an acidic group at this alpha carbon. Compounds such as amino acids that can act as either an acid or a base are called amphoteric. The basic amine group typically has a pK between 9 and 10, while the acidic carboxylic group has a pK that is usually close to 2. The pK of a group is the pH value at which the concentration of protonated group equals that of unprotonated group. Thus, at physiological pH about 7 to 7.4, the free amino acid exists largely at a dipole. This is called Zwitter ion. So this is a German word. What is the meaning? It means hybrid ions. So a Zwitter ion carries both positive charge and negative charge, and in equal amount. So the net charge is 0. Any free amino acid and likewise any protein will at specific pH exist in the form of a Zwitter ion. Thus, all amino acids and all proteins, when subject to changes in pH, pass through a state at which there is an equal number of positive and negative charges on this molecule. The pH at which this occurs is known as isoelectric pH or isoelectric point. It is denoted as small p, capital I, Pi. So isoelectric pH is very important. So this is the deuteronic form of an amino acids. So basic group, it accepts 1 proton. Acidic group, it donates 1 proton. So it's become NH3 plus and COO minus. So net charge is 0. So this is a Zwitter ion. So classification of amino acids based on polarity. There are 5 types of amino acids: non-polar aliphatic amino acids, polar uncharged amino acids, aromatic amino acids, then acidic amino acids, and basic amino acids. So group 1 is non-polar amino acids. They are basically glycine, alanine, valine, leucine, isoleucine, proline, phenylalanine, methionine, and tryptophan. The R groups of these amino acids have either aliphatic or aromatic groups. This makes them hydrophobic. Now you can see several examples: alanine, valine, leucine, glycine, isoleucine, methionine, tryptophan, phenylalanine, and proline. These are amino acid of group 1, that is non-polar amino acids. Next is type 2, that is polar amino acids. Polar amino acids are serine, cysteine, threonine, tyrosine, asparagine, glutamine. The side chains in this group possesses a spectrum of functional groups. However, most have at least one atom with electron pairs available for hydrogen bonding to water and other molecules. So they are serine, cysteine, asparagine, glutamine, and threonine, tyrosine. Next is group 3, acidic amino acids. The 2 amino acids in this group are aspartic acid, glutamic acid. Each has a carboxylic acid on its side chain. So there is an extra carboxylic group of present in these amino acids, and due to presence of this extra carboxylic group, these amino acids become negatively charged. In an aqueous solution at physiological pH, all 3 functional groups on these amino acids will ionize and giving an overall charge of -1. So what are the 3 functional groups? One is NH2 group, that is amine group. Another is the COOH group, and extra COOH group present in the side chain. So they are aspartic acid and glutamic acid. Next is group 4, that is basic amino acids. The 3 amino acids in this group are arginine, histidine, and lysine. Each side chain is basic. Lysine and arginine both exist with an overall charge of +1 at physiological pH. The guanido group in the arginine side chain is the most basic of all R groups, effect reflected in pK value of 12.5. So lysine, arginine, and histidine are basic amino acids. Last but not the least, aromatic amino acids. An aromatic amino acids is an amino acid that include an aromatic ring. Among the 20 standard amino acids, the following are aromatic: phenylalanine, tryptophan, and tyrosine. Now, tyrosine has got an OH group. It makes the polar amino acids because this OH can form hydrogen bond with water molecule or any other polar molecule. So it is a polar amino acids which has an aromatic ring structure. Next is histidine. It contains an aromatic ring which has got NH with this ring structure. Due to presence of this NH, it can accept hydrogen ion. The proton accepting property gives rise to its basic nature. So histidine basically aromatic amino acids having basic property. So phenylalanine, tyrosine, tryptophan, histidine. So these are the 3 things we have completed in our lecture. We have discussed the definition of amino acids, then the basic structure of amino acids, then acid-base properties, and lastly, classification of amino acids. So thank you for your waiting.